The morning Earth changed. Imagine waking before sunrise. The world outside is still dark. The streets are silent, the oceans are calm, and for a few seconds everything feels exactly as it always has. Then a pale light appears on the horizon. One sun begins to rise, but before its full disk clears the edge of the world, another glow appears beside it, brighter, whiter, impossible. A second sun is climbing into the sky. Love space, science, and cosmic mysteries. Subscribe to the Cosmic Earth and join the adventure. At first, the sight would be beautiful. Two stars hanging above the same horizon, two sources of light pouring across the clouds, two brilliant disks turning morning into something no human being has ever seen on Earth. Buildings, mountains, trees, and people would cast double shadows. One might be long and soft, the other could be short and sharp. As the suns moved, those shadows would cross, separate, and rotate across the ground. It would feel less like Earth and more like standing on a distant world. But the second sun would not simply change the view, it would change the meaning of day. Our planet currently receives nearly all of its light and heat from one star. That single source helps control mornings, seasons, weather, oceans, and life. Add another star, and every one of those systems must find a new balance. The most important question would be simple: where is the second sun? If it appeared as close and bright as our present sun without anything else changing, Earth would receive far more energy. Temperatures would begin to rise, ice would melt faster, oceans would absorb enormous amounts of heat, weather systems would grow more violent, and parts of the planet could eventually become too hot for familiar life. But a real two-sun Earth would not necessarily receive twice as much heat. The outcome would depend on the stars themselves. Both might be smaller and dimmer, or one could be a faint red dwarf. They might orbit close together while Earth circles both of them from a much greater distance. This is called a circumbinary orbit, Earth circling a pair of stars locked in a gravitational dance. From the planet's surface, the suns might appear to move around each other. Sometimes they would stand far apart. Sometimes they would draw close. At times, one might pass in front of the other, briefly darkening the middle of the day before the hidden star emerged again. The sky itself would seem alive, but beauty does not guarantee stability. Two stars pull on everything around them. Their gravity would tug at Earth from constantly changing directions. If the planet orbited too close to the pair, its path could become unstable. It might swing dangerously near the stars, drift far away, or even be thrown out of the system. So, for Earth to survive, the arrangement would need to be precise. The two stars would likely have to orbit close to each other. Earth would need to stay far enough away for their combined pull to behave almost like one central object, allowing stability for billions of years. And that is not only science fiction. Astronomers have discovered planets that orbit two stars. They prove planets can survive in binary systems, but an Earth-like world faces a harder challenge. It would need liquid water, a stable atmosphere, survivable temperatures, and enough time for life to evolve. Even if all of that were possible, the first morning under two suns would immediately reveal that this was not the Earth we know. Sunrise might not happen once. One star could rise first in dim red light, followed later by a brighter, hotter second dawn. At other times, both might rise together. Some evenings could have two sunsets. One sun might disappear below the horizon while the other remained above it, stretching daylight far beyond what humans expect. Night might arrive slowly, or suddenly, or not at the same time in every season. Clocks would still count hours, but nature would no longer follow their simple rhythm. Birds might call after the first sunrise. Plants could turn from one star toward the other. Predators would wait longer for darkness, while human sleep cycles began to drift. And the familiar boundary between day and night would become uncertain. Then there would be the color of the sky. If both stars were similar to the sun, daylight might be intensely bright and almost white. If one were cooler and redder, dawn could begin in deep crimson before changing into golden light. Clouds might glow with two different colors at once. Rainstorms could form beneath a sky divided between orange and pale blue light. Every sunrise and sunset would become a spectacle. But beneath that beauty, the atmosphere and oceans would already be responding. More light means more energy. Different angles of sunlight mean different heating patterns. And changing distances between Earth and the two stars could cause temperatures to rise and fall in ways our present seasons never do. The first day would be unforgettable. The first week would be confusing, but the real transformation would take much longer. Because the greatest danger of two suns would not be the sight above us. It would be the slow changes beginning everywhere below, in the winds, in the ice, in the oceans, in the forests, and in every living thing that evolved beneath a single star. Earth might survive its new sky, but it would never again be the same planet. A sky that never behaves the same under two suns, no day would feel completely ordinary. The sky would no longer follow one simple cycle. Instead, every morning, afternoon, and evening would depend on the changing positions of two stars. Some days might begin with both suns rising almost together. The first would appear near the horizon, followed only minutes later by the second. Their combined light would flood the landscape. Mountains would glow from two directions. Trees would cast overlapping shadows. Cities would seem surrounded by light. But on other days, the suns might rise hours apart. One star could begin the morning alone. Its light might be dim, red, and gentle. Then later, the second sun would rise. Suddenly, the sky would brighten again. It would feel like morning happening twice, a second dawn, a second beginning, and that strange rhythm would affect everything living beneath it. Plants on Earth evolved around one predictable source of light. They open leaves, release chemicals, move water, and perform photosynthesis according to cycles of day and night. Under two suns, those cycles could become much more complicated. Some plants might react to the first light, others could wait for the brighter star. Flowers might open twice. Leaves could slowly rotate throughout the day, turning from one sun toward the other. Entire forests might appear to move as the stars crossed the sky. But more light would not always mean better growth. Plants also need darkness. During the night, they regulate energy, repair tissues, and respond to biological clocks built over millions of years. If the second sun remained above the horizon after the first had set, nights could become much shorter. In some seasons, true darkness might last only a few hours. In others, it might almost disappear. That would place enormous pressure on life. Many animals depend on darkness to survive. Owls hunt in low light. Bats emerge after sunset. Insects use the moon and stars to navigate. Predators rely on shadow. Prey rely on darkness for protection. But beneath two suns, the night might no longer arrive in a predictable way. One sun could set while the second remained high. The world would enter a strange half-evening. The sky might darken on one side while still glowing on the other. Animals that normally wake at sunset would not know when to emerge. Some might begin hunting too early. Others might wait too long and lose valuable feeding time. Over generations, species would have to adapt. Those that could not change quickly enough might disappear. Humans would also struggle with the new light cycle. Our bodies are controlled by circadian rhythms. These internal clocks help regulate sleep, body temperature, hormones, digestion, and alertness. They are strongly influenced by light. On present-day Earth, the rising sun tells the body to wake. Darkness signals that it is time to rest. But with two suns, those signals could conflict. The first sunset might begin releasing sleep hormones. Then the second sun could remain above the horizon, keeping the brain alert. Millions of people might experience insomnia, exhaustion, and confusion. Homes would need stronger shutters. Cities might build artificial darkness into bedrooms, hospitals, schools, and workplaces. Night would become something humanity had to create. And even when both suns finally disappeared, the darkness might not last long. The first could rise again before the body had completed a full sleep cycle. Civilization would probably stop measuring the day only by sunrise and sunset. Schedules would depend on artificial clocks more than ever. A workday might begin after the first sunrise. Schools might open after the second. Cultures could develop names for different types of morning: the dim dawn, the bright dawn, the double noon, the first sunset, the final sunset. Time itself would feel different. Then there would be the shadows. Every object would cast two of them. A person walking across a field might see one shadow stretching to the left and another pointing behind them. As the suns moved, those shadows would change length at different speeds. At certain moments they could overlap and appear as one, then slowly separate again. This would make the landscape look unfamiliar even when nothing had physically changed. Forests would be filled with crossing bands of darkness. Rock formations would produce complex patterns. Inside cities, towers and buildings could create moving zones of shade that shifted throughout the day. Architecture would adapt. Homes might need roofs designed to block light from two directions. Solar panels could rotate between the stars. Street layouts might be planned around changing heat and shadow patterns. Public spaces would require large, shaded areas where people could escape the constant brightness. But one of the most dramatic changes would happen during eclipses. On our Earth, a solar eclipse occurs when the moon passes between the planet and the sun. Under two suns, eclipses could become far more complex. The moon might block one star while the second remained visible. The world would dim, but not become dark. A bright ring could disappear from one side of the sky while the other sun continued shining. At other times, the stars themselves might eclipse each other. One could pass in front of the other as they orbited their shared center of gravity. If the larger star blocked the smaller one, daylight might weaken slightly. But if the dimmer star passed in front of the brighter one, the drop in light could be sudden and dramatic. The temperature might briefly fall. Animals could become silent. Plants might respond as if evening had arrived. Then the hidden sun would return. These events might happen regularly enough to become part of calendars. People could predict them, celebrate them, fear them, or build entire religions around them. Ancient civilizations on such an Earth might see the two suns as gods chasing each other through the sky. An eclipse could be interpreted as conflict, a double sunrise as rebirth. A rare moment when both stars set together might become sacred. But behind mythology, the physics would continue. The positions of the stars would change the amount of light reaching Earth. Sometimes the planet might receive energy from both at nearly equal strength. At other times, one star could be partly hidden or farther away. Those differences might appear small, but across an entire world, small changes in energy can reshape clouds, winds, rainfall, and temperature. The sky would never be only a background. It would control the planet below. Every sunrise would carry information. Every shadow would show the position of two moving stars. Every sunset would remind humanity that darkness was no longer guaranteed. And as people learned to live beneath this restless sky, a deeper problem would begin to emerge. The suns would not only change the length of the day, they would begin to change the seasons themselves. When the seasons lose their rhythm on our Earth, the seasons feel predictable. Summer arrives, temperatures rise, days grow longer, then autumn comes. The air cools, winter follows, and eventually, spring returns. This cycle is controlled mainly by Earth's tilted axis as the planet travels around one sun. But beneath two suns, the seasons could become far more complicated. Earth would not simply move through one pattern of light and heat, it would move through the combined influence of two stars. Sometimes the stars might appear close together in the sky, sometimes they would separate. At certain points in Earth's orbit, both could send strong light toward the same hemisphere. At other times, one might be partly hidden behind the other. The amount of energy reaching the planet would constantly shift. And even small shifts could have enormous consequences. The first change would be temperature. If both stars were bright and sun-like, Earth could receive too much heat. Average global temperatures would rise, glaciers would begin retreating, sea ice would shrink, permafrost would thaw, and oceans would absorb more energy every year. But if one star was smaller and dimmer, the planet might remain habitable. The second sun could add only a moderate amount of warmth. That sounds safer, but stability would still depend on distance. If Earth's orbit moved slightly closer to the binary pair, summers could become far hotter than anything humans currently experience. If it moved farther away, winters could deepen quickly. The difference between survival and disaster might be only a small change in orbital position, and the climate would not respond instantly. Oceans store heat. Ice reflects sunlight, clouds trap and block energy. Forests release water into the atmosphere. These systems interact over months, centuries, and even thousands of years. That means the planet could continue warming long after the most intense period of sunlight had passed, or remain cold even after the stars appeared brighter again. Earth's seasons would no longer feel like a simple calendar. They could become delayed, uneven, and unpredictable. One year might bring a long, burning summer. The next could have a shorter, warm season followed by a sudden deep freeze. Some regions might receive heat from both suns for months. Others could remain beneath heavy cloud and weak light. The familiar pattern of 4 seasons might begin to disappear. In its place, humanity might experience entirely new climate phases. Double summer, dim winter, long dawn season, or years in which the planet never fully cools. The oceans would be among the first major systems to change. They move heat around the planet through enormous currents. Warm water travels away from the equator. Cold water sinks near the poles. These movements influence rainfall, storms, and regional temperatures. But under 2 suns, heating patterns could shift across the surface. One side of an ocean might become unusually warm, while another remained cooler. Currents could weaken, change direction, or become unstable. Coastal climates that had remained mild for centuries could suddenly change. Some regions might face extreme heat. Others could become colder, despite receiving more total sunlight. That is because climate does not depend only on how much energy arrives, it also depends on where that energy goes. Then the atmosphere would react. Warmer oceans release more water vapor. More water vapor can strengthen storms. Rainfall could become heavier in some regions and disappear from others. Monsoon systems might shift hundreds of kilometers. Deserts could expand. Forests could dry out. Or areas that were once dry might experience relentless flooding. Storm tracks would no longer follow the same familiar routes. Hurricanes could form in places where they had never existed before, and if ocean temperatures rose high enough, storms might become more powerful and last longer. But heat would not be the only danger. Two suns could also create periods of reduced light. If the stars regularly eclipsed each other, Earth might experience repeated drops in incoming energy. Most eclipses would be too short to freeze the planet. But if orbital cycles caused longer periods of weaker sunlight, the climate could begin cooling. Snow would last longer, ice sheets could grow, more sunlight would be reflected back into space. This could create a feedback loop. More ice causes more reflection causes more cooling, and more cooling creates even more ice. A planet that seemed too warm during one phase could begin sliding toward an ice age in another. The danger would come from the swings. Life can adapt to heat, life can adapt to cold, but rapid movement between the two is far more difficult. Agriculture would become especially vulnerable. Human civilization depends on stable growing seasons. Farmers need to know when rain will come, when frost will end, how long crops will receive sunlight, and whether rivers will carry enough water. Under two suns, those assumptions might fail. A crop planted during a mild season could be destroyed by a sudden burst of heat. Fruit trees might flower early, only to be killed by an unexpected freeze. Rain could arrive too late, or all at once. Entire food systems would need to change. Farmers might stop relying on traditional calendars. Instead, satellites and climate models would track the positions of both stars. Planting seasons could be calculated from orbital forecasts. Heat-resistant crops would become essential. Underground farms might spread across cities. Artificial lighting could protect food production from unstable natural cycles. But poorer regions would struggle. A few failed harvests could create shortages. Long-term instability could cause migration. Millions of people might move toward cooler coastlines higher ground, or polar regions where temperatures remained survivable. Civilization would not only follow rivers and fertile land, it would follow stable light. The polar regions could become especially strange. If the combined warmth of two suns melted large amounts of ice, sea levels would rise, coastal cities would flood, shorelines would move inland. But if the planet later entered a colder orbital phase, some of that water could freeze again. Sea levels might rise and fall over centuries. Entire landscapes could appear and disappear. New islands could emerge. Old cities could be buried beneath water, and populations would be forced to move repeatedly. This would make Earth feel temporary. No climate zone would seem permanent. No coastline would feel safe forever. Even the habitable zone itself would be more complex. Around one star, scientists can estimate the region where liquid water might exist on a planet's surface. Around two stars, that region can shift. As the stars orbit each other, their combined brightness changes slightly. Earth might spend most of its time inside a comfortable zone, but during certain phases it could receive too much heat. During others, too little. To survive, the planet would need an atmosphere and oceans capable of absorbing these changes. A thick atmosphere could spread heat more evenly. Large oceans could act as climate buffers. Clouds might reflect excess sunlight. Life itself could help regulate the environment, but there would be limits. If the stars became too bright, oceans could begin evaporating faster. More water vapor would trap more heat. The planet could enter a runaway greenhouse effect. Temperatures would continue rising until surface water became impossible. Earth would begin moving toward a world more like Venus, but if the suns were too dim or too distant, oceans could freeze. Ice might spread from the poles toward the equator. The planet could become a frozen sphere, a snowball Earth beneath two pale stars. Between these extremes lies a narrow path, a world warm enough for water, cool enough for oceans to remain, stable enough for life, and protected from sudden orbital chaos. That path is possible, but it would be fragile. Every season would be a reminder that Earth's climate was controlled by a moving pair of stars. Every harvest would depend on their dance. Every storm would carry the energy of two suns. And every civilization would live with the same fear. Not that the planet would change, but that one day it might change faster than life could follow. If Earth had two suns, life would not simply continue beneath a brighter sky. It would evolve into something entirely unfamiliar. Every living organism on this planet carries the history of one star. For nearly 4 billion years, life has adapted to one sunrise, one sunset, one predictable rhythm of light and darkness. That rhythm shaped every forest, every ocean, every insect, every bird, every mammal, and eventually every human civilization. But remove that certainty, and evolution begins writing a different story. The first changes would appear in the plants. Today, nearly every green leaf exists for one purpose: to capture sunlight efficiently. The green color comes from chlorophyll, the pigment that absorbs red and blue wavelengths while reflecting green light. It works remarkably well beneath our sun, but beneath two suns, the spectrum of light could be completely different. If one star resembled our sun while the other was a cooler red dwarf, plants would receive energy across a much wider range of wavelengths. Evolution would respond. Some plants might remain green, others could slowly develop darker pigments, deep purple, dark red, almost black. Instead of reflecting large amounts of sunlight, darker leaves might absorb far more energy while protecting delicate cells from excessive radiation. Entire forests could appear black from above, not because they were dead, but because evolution had found a better solution. Imagine flying over a continent where forests shimmer with dark crimson leaves beneath twin suns. It would not look like Earth. It would look like another planet. Flowers would also change. Their colors evolved partly to attract pollinating insects under our sun's light. But different stars create different skies: bees, butterflies, birds. Even their vision could slowly evolve. Flowers might glow in wavelengths invisible to human eyes. Fields could appear ordinary to us, while insects saw brilliant patterns guiding them toward nectar. The relationship between plants and pollinators would evolve together. One could not change without the other. Then the animals would begin adapting. Predators hunt using vision shaped by one daytime star. Prey escape by recognizing familiar shadows. But under two suns, shadows would never behave normally. Every movement would produce two shifting silhouettes. Predators might find it harder to judge distance. Prey could become more difficult to track. Some species would evolve sharper depth perception, others might rely less on vision altogether. Hearing, smell, vibration, electroreception. Natural selection would favor whatever worked best in this brighter, more confusing world. Birds would face another challenge. Many migrate using the position of the sun, stars, and Earth's magnetic field. Now, there would be two suns moving across the sky. Navigation would become more complex. Migration routes followed for millions of years might slowly change. Entire ecosystems could shift northward or southward as species searched for more stable environments. Marine life would also feel the difference. Tiny plankton floating near the ocean surface depend on sunlight. They form the foundation of nearly every marine food chain. If sunlight became stronger or lasted longer, plankton populations could explode in some regions while collapsing in others. Fish would follow their food, whales would follow the fish, predators would follow everything else. The oceans themselves would slowly reorganize. But perhaps the greatest biological challenge would not be physical. It would be time. Nearly every organism on Earth possesses an internal biological clock. These circadian rhythms control sleep, feeding, reproduction, healing, hormone production, and countless invisible processes. For millions of years, those clocks have been synchronized with one cycle of daylight and darkness. Two suns could disrupt that balance forever. Some species might evolve shorter daily rhythms, others longer ones. Certain animals could become active between the first sunset and the second. A completely new ecological period might emerge, neither day nor night. A twilight world occupied by creatures unlike anything alive today. Humans would not escape these changes. Artificial lighting already affects our sleep. Now imagine living beneath natural daylight that refuses to end. Entire cities might struggle with chronic sleep deprivation. Hospitals would treat disorders caused by disrupted circadian rhythms. Schools, factories, airports, offices, everything would rely on carefully controlled artificial darkness. Bedrooms might become completely sealed from outside light. Governments could regulate dark hours the same way modern cities regulate electricity, because darkness would become a valuable resource. Children growing up beneath two suns might never understand what a truly dark afternoon once felt like. Future generations could read about single-star Earth the way we read about extinct animals. Something fascinating, beautiful, but gone. Human culture would transform alongside biology. Nearly every civilization in history has built myths around one sun. Ancient temples, calendars, religious festivals, harvest celebrations. Even the concept of a single day depends on one solar cycle. With two suns, cultures might worship them separately. One could symbolize creation, the other destruction. One life, the other judgment. Ancient civilizations might build enormous monuments aligned with the rare moments when both suns rose together. Entire calendars could measure the positions of both stars. Festivals might celebrate the first double sunrise of each orbital cycle. Poetry would change. Art would change. Music would change. Languages might develop entirely new words for different kinds of daylight. The first dawn, the second dawn, twin noon, split sunset, final light. Even architecture would evolve. Modern cities are designed around one direction of sunlight. Buildings block heat from one side. Windows maximize daylight from another. Under two suns, heat could arrive from multiple angles throughout the day. Future buildings might rotate. Roofs could unfold automatically. Reflective materials would constantly adjust to protect interiors from changing sunlight. Entire underground cities might become common in hotter regions. Above ground, vast reflective shields could cover streets during the brightest hours. Energy production would also change. Solar panels could generate enormous amounts of electricity. Power shortages might become rare. Entire nations could depend almost entirely on solar energy. But engineers would face new problems. Too much energy, too much heat. Power grids would need systems capable of storing enormous amounts of electricity generated during long periods of intense sunlight. Technology would adapt, just as life would. Yet despite every innovation or despite every scientific breakthrough, one uncomfortable truth would remain. Humanity would no longer control its future as easily as before, because above every city, above every ocean, above every mountain, two stars would continue their endless gravitational dance. Every orbit would slightly change the amount of light reaching Earth. Every century could bring new climate patterns. Every millennium could reshape continents. Life would survive. Evolution almost always finds a way. But survival does not mean remaining the same. After millions of years, visitors from our present Earth might not even recognize this world. The forests would look unfamiliar. The animals would behave differently. The skies would feel alien. Human civilization would exist beneath a calendar no one alive today could understand. Children would draw two suns without thinking. Artists would paint double sunsets as ordinary landscapes. History books would describe a forgotten age when Earth had only one sun. And that idea would sound impossible, almost mythical, because for them, the sky had always belonged to two stars. Yet one final question would remain unanswered. Even if life could adapt, even if civilizations could flourish, could a planet caught between two suns remain stable for billions of years? Or would gravity itself eventually decide Earth's fate? That answer lies far beyond the atmosphere, far beyond the clouds, in the silent dance of two stars whose invisible pull would determine whether this extraordinary world could truly survive or slowly drift toward its ultimate end.